Okay, I'm going to work some of the practice problems for Chapter 4. This section is going to be over Boyle's Law. So you should have filled in your notes using the notes that I posted, the fill-in-the-blank notes. I posted the answers, so you should have already filled those in. And what I'm doing now is just going through some of the problems. So looking at practice problem 4.2. The pressure on 2.5 liters. Now this is a volume. I know it's a volume because of the units liters. And it is the initial volume, so I'm going to call it V1. The pressure on 2.5 liters of an anesthetic gas changes from 105 kilopascals, this is a pressure, P1, to 40.5 kilopascals. This is the second pressure. This is after a change. So we have P1, 105 kilopascals, the original pressure, and P2, 40.5 kilopascals, our new pressure. What will be the new volume? This is our V2 that we're looking for, if the temperature remains constant. So the first thing you want to do is list your givens. V1 is 2.50 liters. P1 is 105 kilopascals. V2 is what we're looking for. And P2 is 40.5 kilopascals. So we're going to write the equation that we're going to use, and we're going to use Boyle's law, which is the pressure times the volume of the initial system is equal to the pressure times the volume of the changed system, or P1 times V1 is equal to P2 times V2. And this is Boyle's law. We're going to rearrange this equation to solve for our unknown, which is V2. So we're going to hold V2 where it is, and we're going to move P2 to the other side. And P2 is going to have to be divided. So we're going to basically take our P1 times V1 and divide it by P2, leaving V2 on the other side. And let me show you how we do that, step by step, instead of just racing through it. So we have P1 times V1 is equal to P2 times V2. So we're dividing both sides by P2 to move it to the other side. Remember, whatever you do to one side, you must do to the other. This cancels P2 on this side. So we end up with a rearranged equation, and I'm just flipping this because I like to have my unknown on the left. My V2 is equal to P1 times V1 over P2. So that is my rearranged equation. So in each one of these problems, you're going to list your givens, you're going to write the equation that you're going to use, and then you are going to rearrange that equation. Please do not put your numbers in there and cross multiply. Do not put your numbers in to this unrearranged equation and just cross multiply. You lose track of units when you do that. Please rearrange your equation. Write the rearranged equation, and then plug in your givens. So we have P1, which is 105 kilopascals. I know you don't have to use the grid. You can use parentheses like they do up here. That's fine. I use the grid simply because that's what I'm used to. V1 is 2.50 liters, and P2 is 40.5 kilopascals. Now it doesn't matter which side I put this on because it's just on the bottom, and it really doesn't matter where on the bottom as long as it's on the bottom. Let's cancel our units. Kilopascals are on the top and the bottom. We're left with units of liters. And remember, we multiply whatever is on the top by whatever is on the bottom. So 105, we're multiplying by 2.5, and then we're dividing it by 40.5. We've got 3 significant figures in this number, 3 in this number. Remember, trailing zeros count if there's a decimal in the number. And this one also has 3. So we have 3 significant figures in our answer. We're going to write 6.48, not 6.48 and everything else after it. Only the significant figures. Remember, that depends on how many significant figures you have in your original data. And remember, in multiplication and division, you choose the least number of significant figures. All right, so let's look at 4.3. A gas with a volume of, here's our first volume, V1, of 4.00 liters at a pressure of, here we have 205 kilopascals, that's our P1, is allowed to expand to a volume of 12.0 liters. So here's our V2. What is the pressure in the container if the temperature remains constant? So we're looking for our P2. So listing our givens, we have 4.00 liters for V1. P1 is 205 kilopascals. V2 is 12.0 liters, and we're looking for P2. So we're going to write the equation that we're going to use, which will be P1 times V1 is equal to P2 times V2. And that is, of course, Boyle's law. You need to know the laws by their names, as well as what they are and what they do. We're going to rearrange this equation to solve for our unknown. So we're going to take our P1 times V1 equals P2 times V2, and this time we're going to hold P2 where it is, and we will divide both sides by V2 to move it to the other side. So V2 cancels on this side, and we end up with our rearranged equation is P2 is equal to P1 times V1 over V2. Alright, so now we're going to plug in our givens and solve. So our P2 is equal to, back, we've got P1, which is 205 kilopascals. Our V1 is 4.00 liters. And our V2 is 12.0 liters. And if I would get a call right now, you would know it. We'll catch that in a minute. Alright, kilopascals are the units that we're left with. Again, we put our numbers into our calculator. We multiply whatever's on the top, divide by whatever is on the bottom. So we have 205 times 4 divided by 12. So we get 68.3 kilopascals. Again, looking at the number of significant figures in our data, we have 3 here, 3 here, 3 here, and that's why I wrote 68.3, not 68.3 with a bar above it. That means that you have a whole bunch more numbers there. We don't. We only have 3. So please remember to use the correct number of significant figures. And I will stop here.